Welcome. Today we're going to talk about some triangle similarity theorems. The first three theorems simply help us identify if two triangles are similar or not. Okay, so the definition of similar would mean that the angles are congruent of two triangles and the sides would be proportional. Now we've been working with proportionality, but we need to just get that back in our heads of how we actually solve proportions and how we can prove things are proportional. So, triangle similarity theorems. The first one that we're going to talk about is called the angle-angle similarity theorem. And the angle-angle similarity theorem says that if two angles in one triangle are similar to two are congruent to two angles in a different triangle, then the two triangles would be similar triangles. Now, in this first triangle, triangle ABC, we can see that angle A is congruent to angle D of this second triangle, triangle DEF. And then we can also see by these arcs here that angle C would be congruent to angle F. Now, because we know that the sum of the angles of a triangle using the triangle sum theorem equal 180 degrees, we also can determine that angle B and angle E would be congruent. Because it doesn't matter what A and C are, we know that angle A plus angle B plus angle C must equal 180 degrees. And if we are given that these two angles are congruent to these two angles, then we also know that angle B would be congruent to angle E. Okay, so we would say that these triangles are similar. Now, similarity, we use this symbol here. It's just one of those. And when we say that two triangles are similar, we actually need to go in the right order. So if we're saying that angle A or triangle ABC, that means angle A comes first. So when we're saying that this triangle is similar to this triangle, we need to go in the same order because it tells us what pieces are similar to each other, are congruent, okay? So if we have triangle ABC, then we would need to follow the arcs to make sure that we're going in the same order. So that's why it would be congruent to triangle DEF. Okay, so whenever you know two angles, you can determine the third. And if you know that two triangles have two congruent angles, then we know that they actually have three congruent angles. So that's important. And that would be one way of determining if two triangles are similar or not. Another way is using the side-side-side similarity theorem. We often abbreviate this as S, S, S. Okay, so the side-side-side similarity theorem would be the SSS. And we know that if the sides of one triangle are proportional to the corresponding sides of another triangle, then the two triangles, I spelled triangles wrong, sorry about that, are similar. Okay, so here we've got triangle ABC, and we're comparing that to triangle DEF. And what we want to see, again, these are in, we need these triangles to be, or these letters to be in corresponding positions. But let's look first at side lengths, okay? And one thing that we know is that the shortest side of one triangle should always correspond to the shortest side of the second triangle. So one way we can do this is simply by looking at lengths of sides. Okay, so I'm going to say let's put all the side lengths for triangle ABC as our numerators, so the top of our ratios, and then all the side lengths for triangle DEF as our denominators, so the bottom part of the ratio. Okay, and then we're going to compare these ratios and see, are they actually in fact proportional? So we've got our shortest side of triangle ABC is 24 inches. So I have 24 inches, and my shortest side of triangle DEF would be 4 inches. Okay, and then my middle length for triangle ABC is 30 inches, and my middle length for triangle DEF is 5 inches. And then my longest side length for triangle ABC is 60 inches. And my longest side length for triangle DEF is 10 inches. Now I need to know, are these ratios proportional to each other, or are these sides proportional to each other? So I'm asking, are these ratios equivalent to each other? So 24 divided by 4 is 6. 30 divided by 5 is 6. 60 divided by 10 is 6. Now, because all of these are the same, then I know that my ratios here are all equivalent. So that means my side lengths would be proportional. Okay, so this works. Another way you can determine is by cross multiplication. And if I cross multiplied 4 times 30, I would get 120. And if I cross multiplied 24 and 5, I get 120. So I know that these, by my cross products, 120 and 120, are equivalent to each other, or we would say proportional. Now I could do the same thing over here, but I'm not going to get 120. Okay, now if I look at 30 times 10, I get 300. And if I look at 5 times 60, I get 300. Okay, so those are the same. So they would be proportional. So we can say that these side lengths are proportional. Now it is imperative or an absolute must that you actually check to see if the sides are proportional to each other. Because if these ratios are not equivalent, then these sides are not proportional and these triangles would not be considered similar. Okay, the last method of determining if two triangles are similar to each other would be the side angle side similarity theorem. Now, if two sides and the included angle are given for two triangles, where the included angles are congruent, okay, so remember in geometry that means the exact same, these angles here have to be the same, then the corresponding sides are proportional, then the two triangles would be considered similar. Okay, so here I can see that by my arcs, I know these angles are the same or congruent. So I've checked that off my list. But now I need to make sure that the sides are proportional. So I'm going to set up my ratios. And here I can say my shortest side from this triangle, and let's call it triangle 1. And we're going to compare it to triangle 2. So this is triangle 2. Now my shortest side of triangle 1 is 10 meters, and my shortest side of triangle 2 is 2 meters. And I want to know, is that equal to my longest side of triangle 1 divided by the longest side of triangle 2? Now, 10 divided by 2 is 5. And 20 divided by 4 is 5. And since 5 equals 5, I can say that my sides are proportional. Now, if I didn't want to check it in that manner, I could use cross products. And if I do that, I have 10 times 4 is 40. And 2 times 20 is 40. And since 40 equals 40, my cross products are equivalent. Therefore, I know my sides are proportional. Okay, you have to check to verify that your side lengths are proportional. You cannot just assume, because given sides and an included angle, that you're told that these triangles are similar. Okay, so you have to identify if they are or are not.